We're starting 3.2, relations and functions. The two main objectives we're going to talk about are identifying functions, finding the domain and range of relations and functions. What we're going to talk about are relations, domains, range, and functions today. We're going to express the relationship or the relation to points 2, 3, 4, 7, 6, 8 as a table, graph, and as a mapping diagram. On the T-chart, I'm going to put the X and the Y. Which numbers are my X values? 2, 4, and 6. Which numbers are my Y values? 3, 7, and 8. Now, make sure that you match them up properly. Now, graphing them. I showed you in class how to make just a quick little graph on your paper, just by making the hash marks and not trying to draw the entire grid. Graphing each one. How do I graph 2, 3? Which way is over? To the right 2, up 3. Everyone always says over for left and right. The next one, 4, 7 means to the right 4, up 7. And the last one is right 6, up 8. There's your 3 points. Are they a perfect straight line? No. They have a little bit of a tail on the end. It's crooked. Now this is the exact same thing here. It's a mapping diagram. What a mapping diagram is. Mapping diagram is sort of similar to a T-chart, except for we don't write repeating numbers. And it doesn't matter about what order they're in either. Like I'm just going to put 2, 6, 4. Because these are my X values. And these are my Y values. And I'll just put 7, 3, 8. Doesn't matter what order. Usually, though, we put them in numerical order. Yeah, I almost said alphabetical. I try to correct myself. So mapping, we're going to put them in order. It doesn't matter, though. So we'll leave it as is so you don't have to erase. Which one does 2 go to? So we put an arrow from 2 to 3. What does 6 go to? 6 goes to 8. So we put an arrow from 6 to 8. And 4 goes to 7. Now looking at the mapping diagram, this only goes to one number. This only goes to one number. The 4 only goes to one number. Since each X only goes to one Y, it's considered a function. Try this one. Do all 3. I have 1, 3, 2, 4, and 3, 5. Make the T-chart or table, graph it, and then do the mapping diagram. Now for the points. What they did is they put in all the X values are 1, 2, 3. Remember the points are always X, comma, Y. The Y values are 3, 4, 5. So I go to the right 1, up 3. To the right 2, up 4. To the right 3, up 5. There's the graph. Now for the map. For the mapping, all the x values goes in the first bubble, all the y values go in the second bubble. They just did straight across. 1 to 3, 2 to 4, 3 to 5. The domain of a relation is the set of the first values. So all of the x values are called your domain. The range is all the second coordinates, or all of your y values. I must have deleted the one slide. So of that previous problem, what were my x values? 1, 2, 3. My domain would have been 1, 2, 3. When you're talking about domain and range, please put the squiggle marks on the beginning and end. The range, what were my y values? My ranges were 3, 4, 5. So if I were to ask what the domain and range is, the domain, you can just put a D. The domain is 1, 2, 3. The range would be 3, 4, 5. It does not matter about order, but usually we put them from least to greatest. It makes it a lot easier. Now I have give the domain and range of the relation. So copy this chart down as best as possible. This is going to be a good one to have in your notes. Now, what type of function is this? We learned this from section 1. It's one of two types. Continuous or discrete, and it is continuous. Why is it continuous? Straight line. There's an infinite number of points in between the two. It's not just at 1, 2, 3, 4. There's an infinite number of points. I have a starting point and I have an ending point. What is my starting point? For my domain. My domains are my x values. So we're talking about these numbers down here. Where do I start at? I start at 1 and I end at 5. And it's every single point in between. All the decimals, all the fractions. Are my endpoints solid or dotted, or solid or open? Solid, so that means they are including it. My domain is 1 is less than or equal to x is less than or equal to 5. Because it's everything in between. This goes back to the first section. This goes back to last chapter. For my range, I look at my y values. So where do I start at on my y's? My lowest point is 3. My highest point is 4. And it's everything in between, right? Three is less than or equal to y is less than or equal to 4. There's your domain and your range. Continuous functions have the less than, greater than symbols. The one word I've been saying occasionally is function. It's a very special type of relation. It's where we have the domain matches up with only one y. Each domain matches up with exactly one y value. The way I like to think of this is like your classroom schedule. How many periods do you have in a day? 8. Every period you're assigned a different classroom, sort of. Sometimes you have a double period or you might be in the same classroom twice. But could first period you be in my room but also be in, I don't know, the art room? Why not? You can't be in two places at once. And that's what a function is. A function, you can't be in two places at once. Give the domain and range of the relation. We're going to tell whether the relation is a function. I have the points 3, -2, 5, -1, 4, 0, and 3, 1. Just write this down, then we'll explain. What's my domain for the first or for the function or for that relation? 3, 5, 4, 3. What did I do? I didn't put the second 3. I just wrote 3, 5, 4. Now you can write 3, 4, 5. You can write 3, 5, 4, 3. If you write the repeaters, that's fine. If you don't, you don't. If you put them in order, that's fine. Even though 3 is written in the domain twice, we only write it once when you're given the domain. It makes it a lot easier if you cut out all the repeaters. Plus, it helps me on this part. What's my range? -2, -1, 0, and 1. Think of this like my mapping. 3 goes to -2. 5 goes to -1. 4 goes to 0. How could third period I be in room -2 and room 1? I know it doesn't make sense to say room -2. But could I be in two places at once? No, because 3 goes to two different places. This relation is not a function. Each domain value does not have exactly one range. If you look at it, how many domains do I have? 3. How many ranges do I have? So something has to repeat, right? If you have that mismatch, you have less domains than ranges, then we know we probably don't have a function. Yes. Because if you think of this schedule, could first period you be in my room? Second period you be in my room? Third period you be in my room? Fourth period you be in my room? Could you have a schedule like that where you're in the same room all day long? It is possible. That is a function. But it's impossible to be in two classrooms at once.